Okay, so let's read this next one. It says there's 8 total coins, so that's our total amount right there. It says 3 pennies, 2 nickels, and 3 dimes are placed in a single stack. How many different stacks are possible? Because it's stacking it, order matters. And when order matters, traditionally we want to use permutations. But what we have to realize here is we have multiples of the same thing. So this is when we have order matters, but we have repetition. Anytime we do that, we want to use the previous formula on the previous page. So the formula to find the distinct ones when you have repetition is the total factorial on top and then the factorial for each of the repetitions on bottom. Our total on top, we had 8 coins, so that would have been 8 factorial on top. We consider the number of pennies. There were 3 pennies, so there's a 3 factorial on bottom. There was 2 nickels, so there has to be a 2 factorial on bottom. And 3 dimes, so there's a 3 factorial on bottom. A little hint is these 3 numbers on bottom, the 3, the 2, the 3, should always add up to be the same number on top. So 3 plus 2 plus 3 is 8, and that is 8, which is the same as what's on top. Again, use the fraction button and be very, very careful in your calculator. See what you're going to get. Take a moment right now. I'm getting a total of 560 distinct possible orderings or stacks of these coins. Considering there is repetition, we had to use this formula instead. This next one's actually a little tricky. It says, what if the dimes must stay together? So let's think about that stack, but instead of thinking of it vertically, I'm going to think of it horizontally. So we have 8 separate things that we're trying to organize. So that's 1, 2, 3, 4, 5, 6, 7. There's my 8th one right there. And the idea is we need the dimes to stay together. And there's 3 of them. So there's dimes, dimes, dimes. So then the question becomes, how many ways could I arrange the dimes and how many ways can I arrange everything else? Well, again, the dimes, there's one way to do it. But let's look at the second part. The second part, there's 5 things left. So there's a total of 5 factorial. There is repetition, so I have to do the same as part A. There were... how many? There were 3 pennies, so that would be 3 factorial. And there was 2 nickels, so that would be 2 factorial. So how many ways, considering there is repetition, could I replace the remaining 5 things? That would be, well, it seems to me if I did that in my calculator, I'm getting 10 when I put that into my calculator. So there's 10 ways of arranging the 5 remaining coins. And then the question is, where do I place those 3 dimes? So here I showed placing the 3 dimes in the first thing, but I could have placed those dimes as long as they're together. Let's look at how many different ones that I could have done. Seems to me I could have done the dimes right here, which would have been a second option. In those 3 places, 3rd, 4th, 5th, looks like I have 6 different options that I could have done for placing those 3 dimes just by scooting that 3 pack of dimes to the right one each time. So there's 6 different ways I could arrange the dimes. There's 10 different ways I can arrange the total of the other 5 coins. So if I multiply those together, 6 times 10 would give me a total of 60 different ways that I could arrange the 3 dimes together in the 5 other coins anywhere I wanted throughout the stack. 60 total distinct ways. Okay, so now let's move on to combinations. Combinations. What's the difference between permutations and combinations? Well, first of all, combinations is NCR, not NPR, found in the same place in the calculator. When you hit that PRB button, I believe it's the second number that you do. Again, you're always going to want to do the total or the bigger number first, and then you're going to do what you want second. So what's the only difference between combinations and permutations? Again, you have no repetition here, just like you do with permutations. But the big thing here is order does not matter. So if you watched one of my previous videos when I introduced this section, you might remember that I said, what happens if I wanted to rank the top 3 students in the course versus what happens if I want to take 3 of you out to lunch? When order matters, it's a ranked list. First place, second place, third place. Order actually matters, just like the previous problem. However, when I use combinations, order does not matter. If I take 3 of you out to lunch, it doesn't matter if you were picked first, if you were picked second, or if you were picked third, you're still coming out to lunch. So go ahead and read through these paragraphs, and it will kind of explain that to you. They give a good example with a $1 bill, a $5 bill, and a $10 bill in your wallet. It doesn't matter which order those bills are in, you still have a total of $16 in your wallet. So what's the difference? It's fewer because order doesn't matter. So the number of combinations when order doesn't matter is always smaller than when order does matter. So they give you the formula. Again, I do not care about the actual formula here. I do not care about seeing that on your test. You do need to know the different things. So I could do C, N, K. I could do N, NCR, K. Or I could do N, CK. Let me write that real quick. For any of these numbers, all of those notations are the same dang thing. It just depends which book you're looking at. I tend to use this one in the middle because that's the buttons you push in your calculator. Always you want to do the total number first, the bigger number first, and what you want is your second number. What you want is the second number, okay? Look on the next page. It'll show you how to put this in the calculator, though I already said it. It's still that PRB button in your calculator, and then I believe number 2 is NCR.